All right, so this is lecture 4.5 over the graphs of the sine and cosine functions. And, uh-oh, I'm not plugged in. And we will be looking at the graphs of the other trigonometric functions in subsequent lessons. But these are plenty enough to fill up an entire lesson, probably more than an entire lesson. So we'll go ahead and get moving forward. Okay, so the objectives for this lesson are to understand and graph the sine function and the cosine function. We're going to talk about how these functions can be changed and shift around a little bit, and then we'll look at one application problem right at the end. Okay, so let's go ahead and jump in here. And I put a picture of the unit circle here so that it was clear where I was getting all of these values from. And my suggestion is that as you're working through this homework that you have a copy of the unit circle in front of you, especially this one that has all the points on it. It's got the radian and the degree measures. So I also put, it looks like I covered it with the graph, but this is sine, cosine, and tangent there. And I just put, when we're dealing with the unit circle that has a radius of 1, what the sine of theta, cosine theta, tangent theta, and so on are equal to in regards to the points on the circle. So let's go ahead and get started. We want to take a look at what the graph of the sine of x looks like. And I'm just choosing some points that go around the circle here. So I'm going to choose x equals 0. I'm going to do pi over 6, pi over 4, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 3 pi over 2, and then I shorted myself a slot, so I'm also going to do 2 pi there. All right, so if we look right here in our little unit circle guidance here, we can see that when the radius is 1, as it is with the unit circle, when we take the sine of theta, so any angle that's formed with its terminal side along the positive x-axis, and I'm sorry, the initial side on the x-axis and the terminal side going through a point on the unit circle, we can basically say that the sine of theta is just the y-coordinate for the point that lies on the circle. So if we have the sine of an angle that is 0 degrees, then you can see right there that the y-coordinate for that 0.10 is 0. So pi over 6, so I'm just going to go around and grab these y-coordinates for these particular angles, and I'll just show you what angle I'm talking about. So if I'm talking about the sine of pi over 6, it's that angle there with the point on the circle being square root of 3 over 2 and 1/2. So the sine of pi over 6 is 1/2. The sine of pi over 4 is square root 2 over 2. Sine of pi over 2 is 1. Sine of 2 pi over 3 is square root 3 over 2. Sine of 3 pi over 4 is square root 2 over 2. Sine of 5 pi over 6 is 1/2. Sine of pi is 0. Sine of 3 pi over 2 is -1, and sine of 2 pi is 0. So let me stop here and just make sure that y'all are understanding where I got all those points from. So just give me a green check or a red X. Okay, Mark says yes, Roy says yes. Let's move forward. So now I'm just going to plot these points that I have. So I have the point 0, 0. Let me get a thicker pen here. 0, 0. Pi over 6, I don't have pi over 6 listed on my graph, so I'm just going to kind of skip over that. But it comes out at 1/2. I do have pi over 4 on my graph, and pi over 4 is about square root 2 over 2. However, let me label my y-axis. We'll make this 1 and we'll make this -1. The next one that's easy for me to graph, well, actually pi over 6 isn't that bad because it lies halfway between pi over 4 and 0 there. So that's at 1/2. And then my pi over 2 sits at 1. So you can imagine that pi over 4, which is the square root of 2 over 2, is going to sit about right there. And actually, this pi over 6 is a little off. There we go. All right. And then I went ahead and skipped forward when I was graphing. I went ahead to pi of 0, and 3 pi over 2 is -1, and then 2 pi is 0. So we get this shape of this sine function here. So let me point out a couple of pieces and, use your imagination on this sine curve here. It's not easy using this tablet. Okay, so so you notice I started at 0, 0. I passed through pi 0, dipped down, and then came back up and landed at 2 pi 0. So this is considered one cycle, if you will, of the sine function. So when we've passed through an entire cycle, this is called the period of the function. And then we have, if you notice, we have the same amount with our maximum as we do with our minimum coming from that center x-axis point. And we call that length, we call this length right in here, this distance right in here, the amplitude. And the amplitude's a positive value because it's a distance. So this distance here from the x-axis up to the maximum is equal to this distance from the x-axis down to the minimum because they each go one full unit. And the last thing that I want to point out to you on this graph, I'm just going to highlight these special points here. We have the maximum and the minimum, and we have the 3 x-intercepts for that particular period of the function. So I have my x-intercepts, and then I have my max, and I have my min. When we are graphing these functions, sine and cosine, these are our 5 key points. So if we have these 5 key points, the 3 x-intercepts and the maximum and the minimum, we can graph the function itself. If you notice, I skipped a lot of those values in there. Really, the only reason I put all of these values in the table here was just to show you where these points were coming from. So as you move around the circle, you continue to come back to 0, 1, 0, negative 1, 0, 1, 0, negative 1 in your y values. So if we continued this pattern, you would see that's the case. And we can move backwards through the pattern as well, and the same phenomenon occurs, if you will. So is this an adequate introduction to the idea of graphing the sine function for y'all? Okay, Roy says yes. And Mark says yes. Excellent. Okay, so I wanted to take a look a little bit closer at domain, the range, the period, and the amplitude of good old sine of x, and then I wanted to compare it with 2 times the sine of x so that you can see how these functions begin to change as you multiply by factors or add and subtract different values on. So we could have continued that sine function in both the positive and the negative direction. So the domain for the sine function is negative infinity to positive infinity. And the same with the sine of 2. You can see really the only difference between sine of x and 2 sine of x is the range, which also clues us into the amplitude. So this is also negative infinity to positive infinity because these things continue. The range, let me get a lighter colored pen here. So for the sine function, you can see I'm always going to stay between 1 and negative 1. So that's my range for the sine function, and it's inclusive. So negative 1 to 1, and that's why I'm using the brackets, because it's inclusive. So I'm just trying to remind you of all this old college algebra knowledge while we move forward with the trig. Now, if I take a look at the range of 2 sine of x, you can see it's never going to go above or below 2 and negative 2. So the range for 2 sine of x is inclusive negative 2 to 2 inclusive. All right, the period. Remember, the period is how far one cycle of the function spans. And for both of these, the period is 2 pi. It passes through its 3x coordinates, and it has a minimum and a maximum. So that's going to constitute what one cycle is, passing through the x-intercepts 3 times, or the x-axis 3 times, 1 maximum, 1 minimum. And the amplitude, we'll find out in a moment how to calculate the amplitude, but we can count it here from this picture. So once again, it's that distance from the x-axis to the maximum and the minimum. They're the same. So the amplitude for 2 sine of x is 2. The amplitude for sine of x is 1. Y'all ready to move forward? Great. Okay, so this is just a method of graphing the sine function in the form of a times the sine of some factor being multiplied with the x. And the first example we're going to look at, the factor being multiplied with the x is going to be 1. So we'll see a little bit more of a simplistic graph of sine of x. And then we'll move to looking at one that has a value other than 1 being multiplied with the x variable. So these are just your steps for graphing trigonometric functions, basically, or sine and cosine at least. So you want to identify the amplitude and the period, and when we get into the next problem, I'll tell you how to identify the amplitude without having a graph to look at, as well as the period. And then we'll find those 5 key points, which are your 3 x-intercepts, your max, and your min. And we'll also identify where the value of x starts that cycle, or what value of x starts that cycle, by using this little expression here to find the successive values. And when we haven't shifted this thing at all, which we haven't even talked about yet, you're always going to start with 0. So we'll start with 0 for a few of our problems, and then we'll look at, okay, well, what if we're not starting at 0 and we've shifted this thing? How does that change? Once you find the x values for the 5 key points, of course, you need to find the y values for the 5 key points to get 5 coordinate points. And then you're going to plot those points on the graph, connect them with a curve, a smooth curve, and unless you're Libby and having to use the tablet, and then it's not so smooth. And then you want to look and see what the problem is ask you to use as your domain, and you may need to extend the graph either more to the left or more to the right, or more to the negative side and more to the positive side. So let's go ahead and jump in and work through these steps. Okay, so the first thing that we need to do is identify the amplitude and the period. And here's a little formula for you to find the amplitude and to find the period given an equation here. So what we're going to graph here is 3 times the sine of x. And notice, like I said a moment ago, the coefficient on the variable is 1 there. So in this case, A is equal to 3 and B is equal to 1. So the amplitude. We are told we can find the amplitude of the function by taking the absolute value of A. In this case, that's the absolute value of 3 or 3, meaning we're going to travel 3 units up and 3 units down from the x-axis to reach our maximum and our minimum when we graph this. And then we also need to find the period. And the period is given by 2 pi divided by b. In this case, b is 1. So 2 pi divided by 1 is just 2 pi. So what that's saying is, from 0 to 2 pi is the distance that it takes to complete a full cycle, or move through the x-axis 3 times and you have 1 maximum and 1 minimum. Okay, so finding the values of x for the 5 key points. Well, what we have to know is, well, what is the period divided by 4? Because this is going to tell us what we have to add on to the preceding value to get the next x value. So in this case, the period was 2 pi. So that leaves us with pi over 2 when we divide 2 out of the numerator and the denominator. So we're going to start at 0. So we have our first x value at 0, which means x2 is equal to 0 plus pi over 2. So that leaves us at pi over 2, which is where we start our next x value. X sub 3 is pi over 2 plus pi over 2. I'm sorry, I didn't indicate where I'm getting that pi over 2. That's this value here that we add on to the preceding value to get the next x value up. Periodically speaking, that is. Are y'all following okay so far? Okay, great. So that leaves us at pi there for that one. And x4, so our fourth x coordinate, we start at pi. I'm actually going to write it as 2 pi over 2 instead of simplifying it because I'm adding pi over 2. I want to go ahead and have that common denominator. So that's 3 pi over 2 for x4 and x5. I need to add pi over 2 to 3 pi over 2. And that gives me 4 pi over 2, which is just good old 2 pi. So here are my x values that I'm going to be using. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now I'm going to move forward and figure out what the corresponding y values are for this. Okay, so I have my x values. Let me move my keypad out of the way so I can write the x values. I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I simply plug these values in to find out what the corresponding y values are. So I have y equals 3 times the sine of 0. Well, I know that the sine of 0 is just 0, and that's from my unit circle, which gives me 0. So that is the 0.00. For pi over 2, I have y equals 3 times the sine of pi over 2. So that's 3 times, well, the sine of pi over 2 is 1, and that gives me 3. So I have pi over 2, 3. Y equals 3 times the sine of pi is 3 times the sine of pi is 0. So that brings me back to 0. So you can already see the cyclic, I can't say that word today, the cycle, cyclic, that's what I was trying to say, the cyclic nature of these functions here. Y equals 3 times the sine of 3 pi over 2. So that's 3 times negative 1, because we're at the bottom of the circle there now, which is just negative 3. So that's 3 pi over 2 and negative 3. And then y equals 3 times the sine of 2 pi gives us 3 times 0 brings us back to 0. So we have 2 pi and 0. And note, from our work we have here, here's an x-intercept, here's an x-intercept, here's an x-intercept. The way that sine, or the positive function of sine, is formulated, this is going to be our max, and this is going to be our min, and notice we have positive 3 and negative 3 right there. So all we need to do now is put it on the graph. All right, so let me just give some scaling on my y-axis here. 1, 2, 3. 1, 2, 3. And I'm ready to put my points onto the graph. So I have the point 0, 0. I have the point pi over 2, 3. I have the point pi 0. 3 pi over 2, negative 3. And 2 pi 0. So we go here, and it makes that sound when you do it too, when you're sliding down the hill there. And the only other thing that that I would show you with this problem, you've got an entire period here. However, the problem asks us to graph this for a domain of negative pi to 2 pi. So you just want to follow the pattern here, which means this would be at negative 3 and this would be at negative pi. So to finish off the graph that they ask for, that's what it would look like. So the purple part is the full period, the full cycle there, and then the pink part is just continuing the function through the domain that they ask us to graph it through. And be careful when you're in my math lab, because they will ask you to graph through different or various domains. Did this make sense? Are y'all good? Great and great. Okay, so we have a new function here, and notice, okay, so we've got an A value, A is 2, and now we have a B value. So I'm just going to show you, I mean, it's no different of a process. I'll show you how it changes the way the function looks. So the first thing we want to do is identify the amplitude in the period. So the amplitude is always the absolute value of A. So in this case, it's the absolute value of 2, which is 2. And then I have the period, which is given by 2 pi over B. So 2 pi over 1/2, well, we never divide fractions. And just to point out, because I know a lot of students are weak with fractions or they just don't like to use them, this is a 2 pi over 1. So we have 2 pi over 1. I don't divide fractions. I multiply by the reciprocal, which is 2 over 1, and that leaves me with 4 pi as my period there. Moving forward. Mark, are y'all getting some big snow down in Ackworth? I'm just looking out my window, and I heard that they've changed the forecast for Rome. Originally, they were saying 3 to 5 inches, but it looks like we've probably already got a good 3 inches. They've changed it to 6 to 12 inches for us. Yeah, y'all are still getting good snow. How about you, Roy? Where are you? Oh, you're in Cartersville, and you have a lot, too. Yeah, I think y'all got hit about 30 minutes after we did because it was coming from the west. You've got about 2 now. That's cool, Mark. Yeah, I was supposed to head down to Macon for a conference tomorrow, but that ain't happening for Libby. So I bought sleds this morning, so my husband and I are keeping our fingers crossed that he's going to get off of work tomorrow, and we're going to be sledding down our pasture hill tomorrow. All right, so I've just lost where I was, sorry. Yeah, we had really thick clumps of snow coming down earlier too. It's evened out. I mean, they're big flakes, but they're not the clumps that I was seeing earlier, so I know what you're talking about, Roy. All right, so finding our key points here. The first thing we need to do is find what we need to add on to our beginning value to get our other x values. So that's the period divided by 4. In this case, our period was 4 pi, and we're dividing that by 4. So we're going to add pi on each time to get to our next significant x value. So we're going to start at 0 again, and then we have 0 plus pi, which is pi. Oops, I got way sidetracked writing it. I have no idea why I just wrote a 2 there. The snow's getting me excited. So this is pi plus pi, or 2 pi. Our fourth x value is 2 pi plus pi, which is 3 pi. And our fifth x value is 4 pi. All right, so we're just going to put it into our chart and figure out our y values now. Roy, if you'll stick around after the lecture, after I turn off the recording, I'm going to talk to you about your homework help video. I see that you're typing something, so I'm just waiting to see what you have to say there. I'm going to fill in these values here. One, two, three, four, 5. Oh, I see why I have 5. I have an extra space. I forgot to leave the labels on the, there we go. Now we're fixed. Okay, great. All right, so we have y equals 2 sine of 1/2 times x. So in this case, that's 1/2 times 0. So that's 2 sine of 0. The sine of 0 is 0, so that's 2 times 0, which is 0. So we have the point 0, 0. And y equals 2 times the sine of 1/2 times pi is 2 times the sine of pi over 2. The sine of pi over 2 is 1. So we have the point pi 2. Y equals 2 times the sine of 1/2 times 2 pi. So that's 2 times the sine, that's 2 pi over 2, which is the same thing as pi. The sine of pi is 0, so that's 2 times 0, which is 0. So we have the point 2 pi, 0. Y equals 2 times the sine of 1/2 times 3 pi, which is 2 times the sine of 3 pi over 2. The sine of 3 pi over 2 is -1. And just to remind you, I'm getting the values for these sine functions from my unit circle. So 3 pi, -2. And if you had values that weren't listed on your unit circle, you could use your calculator to get those values. 2 times the sine of 1/2 times 4 pi is 2 times the sine of 4 pi over 2, which is 2 times the sine of 2 pi. The sine of 2 pi is 0, so that is 0. So 4 pi, 0. So once again, I'll just point out real quick, we have our x-intercepts and our max and our min. And notice our max and our min show that amplitude that we figured out earlier. Okay, so we're ready to put everything onto the graph. Let me just label my graph here. So 1, 2, 1, 2, 3. I'm going to put this as pi. I'm going to leave 4 units between these just to spread it out so you can see it a little better. 1, 2, 3, 2 pi. 1, 2, 3, 3 pi. 1, 2, 3, 4 pi. And then I need to go to 2 and negative 2. So 1, 2, 3, 1, 1, 2, 3, 2. 1, 2, 3, negative 1, 1, 2, 3, negative 2. Okay, so like I said, that was just to spread it out. I did not do that for any specific reason. Okay, so I have the point 0, 0. I have the point pi 2. Oops, and I missed it. Missed my mark. Just move it over. There's the marvels of modern technology. 2 pi 0, 3 pi negative 2, and 4 pi 0. So here's our curve. And that's it. And I can't remember, I think they actually asked you to take it to 8 pi, but I didn't have room. So you just, you know, continue the same pattern all the way through. You'd actually, with going to 8 pi, you would double this, you go through 2 periods of it. Does that make sense? Okay, great. Good. I figured it would. Okay, so now what we want to look at is we're kind of adding into this process. So we have an A value being multiplied with a function. We have a B value being multiplied with the X variable. And now we're subtracting a C value. So if you think back to college algebra, when we talked about transformation of functions, we figured out that when you subtract a value on the inside of the function, and this is happening on the inside because we haven't actually taken the sign of that function yet, then you're talking about horizontal shifting. So left and right movement, and you can see in this picture here that they're not starting at the origin. They've shifted to the right a little bit, but the shape is the same. So we find that we can figure out when we've subtracted some value on the inside of the function that that shift is equivalent to C over B. And if C over B, that value of C over B is greater than 0, then it shifts right. If C over B is less than 0, then it shifts to the left. And this is called a phase shift. So like I said, we're just adding another step into this process, which is a movement in the horizontal direction of the function. Okay, so in this particular problem, we are asked to graph 3 times the sine of 2x minus 3 pi. I'm sorry, pi over 3. So A is equal to 3, B is equal to 2, and because subtraction is in the form C is equal to pi over 3. And let me point out that since subtraction is in the form here, that if that C value is added, it's as if you subtracted the negative value. So, for example, say I had, I don't know, 2 sine of 4x plus 7. I would have to think of that as 2 sine of 4x minus negative 7, and my C value would actually be negative 7 there. So I wanted to point out that your C value is positive pi over 3 because minus is in the form. So the first things that we need to do are identify the amplitude, the period, and now the phase shift. So the amplitude is the absolute value of A. That's the absolute value of 3, which is just 3. The period is 2 pi over B, which is 2 pi over 2 in this case, or just pi. And now we have the phase shift to think about, and that's given by C over B. C in this case is pi over 3, and we're dividing that by 2. Whenever I work in fractions, I like everything to look like a fraction, so that's really a 2 over 1. We never divide fractions, we multiply by the reciprocal. So my phase shift is pi over 6. In other words, it's taken that sine function and it shifted it pi over 6 to the right, or in the positive direction. Okay, so finding key points. First, I need to figure out what I need to add on to each of these points to get to the next point. So that's the period divided by 4, which our period was pi, and so I get that I need to add on pi over 4 to get to the next point. Well, my x1 this time is where I shifted to in that period. So my x1 is pi over 6. My x2 is pi over 6 plus the pi over 4. I need to get a common denominator here to be able to add these fractions. So I'm going to multiply this by 2 over 2 to make a 12 in the denominator, and this by a 3 over 3. And I have 2 pi over 12 plus 3 pi over 12. So I have 5 pi over 12, and that does not reduce any further. My third x value, I start with the 5 pi over 12, and I add on pi over 4. But once again, I need to get a common denominator. That's 3 over 3. That's a terrible looking 3 over 3, but that's what it is. 5 pi over 12 plus 3 pi over 12 gives me 8 pi over 12. That reduces a 4 comes out of both 8 and 12 to give me 2 pi over 3. X sub 4, I start out with 2 pi over 3, and I'm adding on pi over 4. Once again, got to get the common denominator. So I'm going to multiply that by 4 over 4, and this by 3 over 3. So I have 8 pi over 12 plus 3 pi over 12, and that lands me at 11 pi over 12. And finally, my fifth point, or my fifth x coordinate, I start at 11 pi over 12. I'm going to go ahead because I know I need the 12 in the denominator, and I know from here That's 3 pi over 12. So I'm just going to go ahead and add 3 pi over 12. So I get 7 pi over, no, I'm sorry, that's an 11. Can't read my own handwriting. Surely Roy would have caught me, though, here in a moment. So that's 11 pi over 12. No, my goodness. I'm adding 14 pi. There we go. Thank you. It reduces to 7. Yes. This is 7 pi over 6. There we go. Thank you, Mark. Now let's put it into our chart and figure out our y values. Okay, so I left myself room to work here, so I've only got part of the chart, and then the other part of the chart is on the next slide. So we have y equals 3 times the sine of 2 times pi over 6 minus pi over 3, and that equals 3 times the sine of 2 pi over 6, and I'm going to go ahead and in my head I'm going to multiply that pi over 3 by 2 over 2, so that's minus 2 pi over 6 for the sake of room here. So I have 3 times the sine of 0. The sine of 0 is 0, so that's 3 times 0, which is 0. So I have the point pi over 6 times 0. I didn't skip too much work in there for y'all, did I? Y'all good? Good and good. Great. Okay. So I'm going to start up here so I have plenty of room for this one. Y equals 3 times the sine of 2 times 5 pi over 12 minus pi over 3. And that equals 3 times the sine of 10 pi over 12 minus, well, pi over 3, if I multiply by a 4 over 4, is 4 pi over 12. And that equals 3 times the sine of 6 pi over 12, which equals 3 times the sine of pi over 2 when I divide a 6 out of both of them. And the sine of pi over 2 is just 1. So I have the point 5 pi over 12 and 3. All right. Y equals 3 times the sine of 2 times 2 pi over 3 minus pi over 3. And that's 3 times the sine of, 4 pi over 3 minus pi over 3, which is 3 times the sine of 2 pi over 3. The sine of 2 pi over 3, whoops, 4 pi over, no, that's 3 pi over 3, my bad. So that's just 3 times the sine of pi. The sine of pi is -1. So this gives me, oh my goodness, my eyes just went way to the wrong line there. The sine of pi is 0. So that just gives me 0. And I have the point 2 pi over 3, 0. Continuing the chart. Okay, 11 pi over 12. Y equals the sine, 3 times the sine, of 2 times 11 pi over 12 minus pi over 3, which is 3 times the sine of, I'm going to go ahead and simplify this here. 2 goes into 2 once and into 12 6 times. So that leaves me with 11 pi over 6 minus pi over 3. I need to get a common denominator there. So this is 3 times the sine of 11 pi over 6 minus 2 pi over 6. And that's 3 times the sine of 9 pi over 6, which is 3 times the sine of 3 pi over 2. The sine of 3 pi over 2 is -1, which gives me -3. So 11, keep drawing the pi symbol for 11. There we go, 11. At least it's easy to turn an 11 into, or turn a pi symbol into 11. 11 pi over 12, -3. And the last one. Y equals 3 times the sine of 2 times 7 pi over 6 minus pi over 3 equals 3 times the sine. I'm going to reduce again here before I multiply. 2 goes into 2 once and into 6 3 times. So I have 3 times the sine of 7 pi over 3 minus pi over 3, which is 3 times the sine of 6 pi over 3, which is the same thing as 3 times the sine of 2 pi. And 3 times the sine of 2 pi, well, the sine of 2 pi is 0. So I end up with 7 pi over 6 and 0. So next step is to put it on the graph. Okay, so we have the points. Let me get my pen here. And let me give a scale as well. I scaled it. I skipped 2 between each of them, and I called this, let me get my black pen to do the scale here. I did pi over 6, skipped 2 and did pi over 3, skipped 2 and did pi over 2, skipped 2 and did 2 pi over 3, skipped 2 and did 5 pi over 6, skipped 2 and did pi, which is 6 pi over 6, skipped 2 and did 7 pi over 6. All right, so we have the points, pi over 6, 0. Then our next point was actually 5 pi over 12 and 3. Oh, I'm sorry, I forgot to do my y-axes as well. Let's see. We'll do, I think I skipped 2 on each of these. 1, 2, and 3. -1, -2, and -3. All right, so 5 pi over 12 actually lives halfway between pi over 3 and pi over 2. So we had the point 5 pi over 12 and 3. Well, it actually lives a little less than, let's see, 6 pi over 12 would be pi, so it lives a little closer to pi over 2 than it does pi over 3. So maybe somewhere right in here. And then we have 2 pi over 3, 0. Then I had 11 pi over 12. That's really close to pi. So I'll go about right here. And you just want to be reasonable with your points. I'm not, well, y'all do it digitally, so I'm sure they'll have it scaled better for you than having to do it by hand. Okay, and I believe they asked us to start at 0 in the original problem, so we would just about right there. And it doesn't quite hit 3 when it's at 0. All right, y'all ready to move forward with cosine? Mark, did you have a question? Okay, great. And I apologize for the length of this lesson. There's no way to shorten it with going through all these graphs. Okay, cosine. All right, so the same deal here. I chose the same values that I chose for sine. So I have 0, pi over 6, pi over 4, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 3 pi over 2, and then 2 pi. And since you already know where the values are coming from, I'm just going to run down here. I have 1, square root of 3 over 2, square root of 2 over 2, 0. Oh, I guess I should point out, now we're looking at our x values. So we're looking at the x coordinate to find the values of the cosine of theta here. Negative 1/2, negative square root 2 over 2, negative square root 3 over 2, negative 1, 0, and 1. And putting this on the graph, we have 0, 1. So I just went up 3 here. I can go up 4 just to make it nice and even. So let me get a different color pen. So we have 0, 1. And then I'm going to go ahead and jump to pi over 2, 0. Pi, negative 1, 2, 3, 4. So here. 3 over pi, 0. And 2 pi, 1. So this is what this thing ends up looking like. Use your imagination as usual. And this is our cosine function. So if you notice, it looks a lot like the sine function does, except shifted a little bit. So one of my old friends from graduate school told me how he always remembered that cosine didn't start at the origin but started at 1. He always said, well, cosine coasts down. So I don't know if that's silly or if it helps you, but that's how he always remembered that cosine wasn't at the origin, because cosine coasts down. All right, so this is just looking at, you know, the cosine information. We have the amplitude and the period given by the same formulas that we used for sine. Okay, I'm looking at the banister on our balcony, and we definitely have like 4 inches right now. This is awesome. Okay, so we're going to look at the graph of -4 times the cosine of pi x. All right, so our first task is to identify the amplitude and the period. So the amplitude is the absolute value of A. Oh, let me identify A and B here. A is -4, B is pi in this case. So the period is given by 2 pi over, oh, I forgot to finish the amplitude. The amplitude is the absolute value of -4. So I have an amplitude of 4. Period is given by 2 pi over b, so that's 2 pi over pi. My pi's divide out, and I have a period of 2. All right, and now we're ready to find our 5 key points. So I need to figure out, well, what is the period divided by 4? The period is 2, so that leaves me with 1/2. That's what I'm going to add on to each of the subsequent x values. So I start at 0 because I haven't shifted. I have no phase shift, so I'm always going to start at the origin in that case. 0 plus 1/2 gives me 1/2. 1/2 plus 1/2 gives me 2/2, or 1. I'm going to call it 2/2 plus 1/2 gives me 3/2. And 3/2 plus 1/2 is 4/2, or 2. So it's nice to be working All right, I accidentally hit it too many times there. Let me go back a slide. All right, here we are. So it's nice to be working with values that are familiar with this one. All right, so we have y equals -4 times the cosine of pi times, let me write that as a dot so I don't have 2 parentheses right next to each other, pi times 0, which is -4 times the cosine of 0. The cosine of 0 is 1, and that leaves me at -4. So I have the point 0, -4. And then y is -4 times the cosine of pi times 1/2, which is -4 times the cosine of pi over 2. The cosine of pi over 2 is 0, so that's just 0. Sorry, my brother is trying to call me. He's in Canton, and so I'm sure he's calling me about the snow. All right, y equals -4 times the cosine of pi times 1, -4 times the cosine of pi. is just -4 times -1 or -4. So I have 1, -4. Moving forward, I'm sorry, that's +4. There we go. Negative times a negative is a positive. All right. So this is y equals -4 times the cosine of pi times 3/2, which is -4 times the cosine of 3 pi over 2. And the cosine of 3 pi over 2 is 0. So I have 3 pi over 2, 0 there. And the last one, -4 times the cosine of pi times 2, -4 times the cosine of 2 pi, and the cosine of 2 pi is 1, so I get -4, and that's the point 2, -4. Putting it on the graph. All right, I'm just going to label my axes here. I have 1, 2, 3, 4, because I know my amplitude is 4. So I need 4 in both directions here. And 1, 2, 3, I made this 1/2. 1, 2, 3, 1. 1, 2, 3, 3/2. 1, 2, 3, 2. If y'all hear guitar playing, mad guitar playing in the background, that's my husband. He's got his headphones on, but I can still hear it. I don't know if the recording's picking it up or not. All right, we have the point 0, -4, the point 1/2, 0, the point 1/4, the point 3/2, 0, and the point 2, -4. So, whoa, that was bad. Oh, and I went all the way down. Yeah, well, y'all get the point. It should be, no pun intended there, by the way. That should be 1 up. I'll correct it this way. Oh, wow, I didn't know it would do that. I had that highlighted and didn't realize that it would actually change the color of that thing. So it should be here. Sorry. All right, that's it. Y'all ready to move forward? All right. Okay, so I'm adding a piece to the puzzle here. We have a subtraction, so we have a phase shift happening. Same information here as it was for the sine function, so we'll go ahead and move forward. Okay. So we are being asked to graph 3/2 times the cosine of 2x plus pi. First thing we need to do is identify amplitude, period, and the phase shift. The amplitude is given by the absolute value of A. Let me identify my A, B, and my C real quick. My A is 3/2, my B is 2, and my C is pi. Okay, so this is the absolute value of 3/2, which is just 3/2. My period is given by 2 pi divided by b. So that's 2 pi divided by 2, or pi. And my phase shift is given by c over b, which, okay, so I forgot to point this out. This is a plus sign on the inside of the parentheses here, so this is really minus a negative pi. So my phase shift is negative pi over 2, which is just negative pi over 2. Is that okay? Did y'all catch that? Okay, Mark says yes, and Roy says yes. Excellent. Y'all are such smart gentlemen. Okay, the value between my x-coordinates for my key points is given by the period divided by 4. So that is pi over 4 in this case. We start where we shifted to, which was negative pi over 2. So my x2 is negative pi over 2 plus pi over 4. Need to get that common denominator, so this is negative 2 pi over 4 plus 1 pi over 4, which leaves me at negative pi over 4. My third x-coordinate is I start at negative pi over 4, I add pi over 4, so that's just 0. My fourth x-coordinate, I start at 0, add pi over 4, and I land at pi over 4. And my x5 is pi over 4 plus pi over 4, which is 2 pi over 4, or pi over 2 when I simplify. Okay, so we have y equals 3/2 cosine of 2 times negative pi over 2 plus pi, and that's 3/2 times the cosine of, this is negative 2 pi over 2, so this is just negative pi plus pi, which is 3/2 times the cosine of 0, which is 3/2 times 1. The cosine of 0 is 1, or 3/2. So this is the point negative pi over 2 and 3/2. All right, negative pi over 4, I have y equals 3/2 times the cosine of 2 times negative pi over 4 plus pi, and that's 3/2 times the cosine of negative pi over 2 plus, I'm not going to add pi, I'm going to add 2 pi over 2. So I've just gotten my common denominator there. And this is 3/2 times the cosine of pi over 2. And the cosine of pi over 2 is 0. So I have the point negative pi over 4, 0. Okay, so y equals 3/2 times the cosine of 2 times 0 plus pi. Well, that's just 3/2 times the cosine of pi. The cosine of pi is negative 1. That's negative 3/2. So that's the point 0, negative 3 halves. All right, y equals 3 halves times the cosine of 2 times pi over 4 plus pi. And that is 3 halves times the cosine of pi over 2 plus, I'm going to go ahead and get my common denominator, 2 pi over 2, which is 3 halves times the cosine of 3 pi over 2. And the cosine of 3 pi over 2, I started writing cosine again. The cosine of 3 pi over 2 is 0. So we have pi over 4, 0. And we've got one more point to go. Okay, so y equals 3 halves times the cosine of 2 times pi over 2 plus pi. Well, that's 3 halves times the cosine of pi plus pi, which is 3 halves times the cosine of 2 pi. And the cosine of 2 pi is 1. So I have the point pi over 2 and 3 halves. Okay, so just to put it on the graph here, let me give you my scale. Let's see, 1, 2, 3. I did this negative pi over 4. 1, 2, 3. This is negative pi over 2. I have 0, 1, 2, 3. This is pi over 4. And 1, 2, 3, pi over 2. And I need to go up 3 halves, which is 1 1/2, and down 3 halves. So this will be 1/2. This will be 1, and this will be 3 halves. This is negative 1/2, negative 1, and negative 3 halves. All right, let's put this on the graph. So negative pi over 2, 3 halves. Uh-oh, my keypad's in the way. Here we go. 3 halves. Pi over 4, 0. 0, negative 3 halves. Pi over 4, 0. And pi over 2, positive 3 halves. So we have this happening. And that's it. Y'all ready to move forward? We have one more graph and then our application problem to look at. Like I said, I apologize that this ran so long. There's just a lot to get through. Okay, so vertical shifts of sinusoidal graphs. I did not go into detail about what a sinusoidal graph is, but it's any function that can be written as a sine function. And the reason they call the cosine a sinusoidal graph is because all it is the graph of the sine function shifted pi over 2. So that is the definition of a sinusoidal graph. So both sine and cosine are considered sinusoidal graphs. All right, so we have the sine and the cosine here. And now we have an added value onto the end here. And once again, if you think back to college algebra, when you added or subtracted a value outside of the function, so I've already taken the sine or the cosine here, and then I tack on a value to the outside, that causes a vertical shift in the graph here. So when we have our amplitude, if we've shifted vertically, then we have to add that shift onto our amount or our distance of our amplitude, length of our amplitude. Okay, so step one is to identify amplitude, period, phase shift, and now vertical shift. So we have amplitude, absolute value of A is the absolute value of 2. I always forget to go and identify these first. So A is 2, B is 1, C is 0 because we're not subtracting or adding a value before we take the cosine, and D is 1. Okay, so period, we have 2 pi over B, which is 2 pi over 1 or 2 pi. The phase shift, C over B, is 0 over 1, which is 0. So I've had no left or right movement here. And now the vertical shift. Well, it's just given by D there. So it is a positive 1 shift since we're adding 1 onto our function there. Okay, and I didn't really talk about what a vertical shift was, but if you have the cosine function here, all it does, it doesn't change the shape of it, it just moves it up or down, depending on if you're adding or subtracting that D value. So I just wanted to clarify that real quick before we move forward. We have not shifted left and right. We had no phase shift. So our x1 value is 0. And I need to figure out how much I need to add on to each of those values. So it's the period divided by 4, which is 2 pi divided by 4, or pi over 2. So our x2 is pi over 2. Our x3 is 2 pi over 2, which is just pi. Our x4, I'm going to write 2 pi over 2, which is where we start, and then add that pi over 2. So 3 pi over 2. And our x5 is 4 pi over 2, which is equals 2 pi. All right, so we have y equals 2 times the cosine of 0 plus 1. That is 2 times, the cosine of 0 is 1. So that's 2 plus 1, which is 3. So we have the point 0, 3. Y equals 2 times the cosine of pi over 2 plus 1. Well, the cosine of pi over 2 is 0. So that's 0 plus 1, or 1. Pi over 2, 1. We have 2 times the, I'm trying to speed through this if you can't tell. I know I've had y'all here for a long time this evening. I really appreciate y'all sticking with me. The cosine of pi is -1. That's negative 2 plus 1 or negative 1. So pi negative 1, and y equals 2 times the cosine of 3 pi over 2 plus 1. The cosine of 3 pi over 2 is 0. So that's 1. So we have 3 pi over 2 and 1, and I had to use another slide for the next one. Okay, so y equals 2 times the cosine of 2 pi plus 1. That is 2 times, the cosine of 2 pi is 1. That's 2 plus 1 or 3. So we have the point 2 pi, 3. Going to put it on the graph. Okay, so I forgot to write this when we were doing our amplitude and period and all that, but to find our max and our min in regards to our range, we have D plus the absolute value of A. So in this case, that's 1 plus 2, which is 3. And then we have D minus the absolute value of A, which is 1 minus 2, or negative 1. So on my scale, I only need to show negative 1 up to 3. So 1, 2, 1, 1, 2, 2, 1, 2, 3 is that line that you can't see there. And then I have 1, 2, 3 pi over 2, 1, 2 pi, or I need to move that over, sorry. So skipping 3, 1, 2, 3 is pi, 1, 2, 3, 3 pi over 2, 1, 2, 3, 2 pi. All right, I'm ready to put it on the graph. My first point was at 0, 3. My next point was pi over 2, 1. Then I had pi negative 1. 3 pi over 2 and 1, and 2 pi 3. So we have this curve. All right, we have an application problem left and then we're done. Y'all ready to move on to it and get done? All right, I agree. Remember how late we sledded to that one time? All right, so we have a region that is 30 degrees north of the equator averages a minimum of 10 hours of daylight in December. Hours of daylight are at a maximum of 14 hours in June, and let X represent the month of each year, so 1 January, 2 February, and so on. If Y represents the number of hours of daylight in the month X, use the sine function of this form to model the hours of daylight. So I'm going to move to a blank slide for us to start breaking this down on. Okay, so it's cyclic, which is why we can use the sine function here. So we have Y equals a times the sine of bx minus c. All right, we were told that our maximum hours of daylight was 14 and our minimum was 10. So this thing's going to be oscillating between 10 and 14. And if you think about it, say we have 14, there's 13, 12, 11, and 10. If 14 is our max and 10 is our minimum, then we had to have an amplitude of 2. So we have an amplitude of 2, and it's oscillating at a D, which is the shift, remember, up. So actually we should put plus D on that, sorry. It shifted this whole thing off of the axis, off of the x-axis up to 12. So our D value is 12 since these hours of daylight are oscillating from that center horizontal line there. So one complete cycle or period is 12 months. So since we know that 12 months is our period, I can say that 12 is equal to 2 pi over b. So I can start picking out the little pieces that I need by putting, putting the puzzle pieces together, so to speak. If I multiply both sides by b here, it gets that out of the denominator, and I'm left with 12b is equal to 2 pi. Divide 2 pi off of both sides, and I get, divide 12 off of both sides, and I get b is 2 pi over 12, which is pi over 6. So far, I have figured out my A value, I figured out my D value, and I figured out my B value. All I need is my C value, and I can write the equation for this phase shift. Now, I have to admit to you, gentlemen, that I cheated and was looking at the PowerPoint when I was going through this problem before I came into lecture. And I was hoping that maybe y'all could help me understand where they got this from. But, you know, C has to do with the phase shift. It's the left and right of the horizontal movement. And they stated at this point of the PowerPoint that your starting point is March. And I don't know where in the problem it would clue you in to know that your starting point is March, but that's an X value of 3. So do either of you have any clue as to where you would get that your starting point is March so that you can figure out what your phase shift is? I'm seeing, okay, Mark's typing something. Maybe he has an answer for us. I'm going to go ahead and put this into our formula to figure out what our phase shift is, or to figure out what our C is. We know that our phase shift is equal to C over B. So, okay, if it day in the problem, no, okay, yeah, it didn't say in the problem to start at March, so I don't know if they left that out of the problem on the PowerPoint, or there's something I'm not picking up on, but some way they figured out that you want to start at 3. So we know what our B value is, and that's pi over 6. And if I multiply both sides here by pi over 6, I get that our C value is equal to 3 pi over 6, which is the same thing as pi over 2. So I have all of the pieces. March is the spring equinox. You're so right about that, but I still have no idea why they would have a start there. All right, we'll just accept it and move on, especially since it's late. All right, so to write the value of our equation, we just have to have our A, B, our C, and our D. And now the equation that models the hours of daylight is y equals 2 times the sine of pi over 6x minus pi over 2 plus 12. Voila, gentlemen, we made it through in a short hour and 42 minutes. And I see, Mark, I see you're typing something, so I'm going to wait and see what you have to say before I bid you good evening. And Roy's typing something too. I'm going to go ahead and cut the recording here.